Hello children. Again we are going to discuss one of the finest examples. In this figure it is given that segment AP, segment BQ and segment CR, three vertical lines, are parallel to each other, and the question says prove that 1 upon AP plus 1 upon CR is equal to 1 upon BQ. Let us start again by separating one triangle from the figure. This triangle, and this is segment BQ. Here we have B, here you have A, and here you have C. Now it will be easier for you to understand, okay? Because these two segments are parallel to each other, therefore angle CBQ, this angle will be congruent to this angle, okay? Similarly CQB, this is the angle, this will be congruent to this angle because these are corresponding angles. Now we have written that corresponding angles are congruent. We have given the reason. We are using these two statements to prove that the triangles are similar. Obviously in triangle CBQ and triangle CPA we have written CBQ CPA, this angle is congruent to this angle is congruent to this angle, therefore the triangles are similar by AA test, okay? CBQ is similar to CPA. CBQ is similar to CPA. Therefore, corresponding sides will be proportional. So, I have written BQ. The corresponding side of BQ will be PA, which can be written as AP also. So, BQ upon AP is equal to QC upon AC. Now, the question lies, sir, why not the third ratio? Because these two segments will be common. These two segments will be common for both the triangles AQ and QC. These segments will be there in the second triangle ARC also. So that will be the deciding factor. Okay, that will be the linking factor of two ratios. So I have included these two segments, segment QC upon segment AC. Okay, now exactly similar situation is there for the second triangle, that is triangle ARC. Let me draw that triangle separately here. Now exactly repeating the same logic, that this angle, these two angles are congruent. Similarly, these two angles are also congruent for the same reason, because the lines are parallel, corresponding angles are congruent, and using these two for proving that the triangles are similar, therefore triangle ABQ is similar to ARC. ABQ is similar to ARC, correct? And therefore you will find BQ upon RC is equal to AQ. If I take AQ this side, I have to take AC this side. AQ upon AC. So see, we are using these segments, segment number 1, segment number 2 and segment full length, that is AC, for the linking of the ratios. Now, after getting this result, I am going to add equation number 2 and equation number 4. Let us add. Adding 2 and 4, we get BQ upon AB, which is this ratio, plus BQ upon RC, that is this ratio, okay? Then you have to add the right hand sides also. If you add right hand sides, you get QC upon AC plus AQ upon QC. Now the question lies, why did I calculate this ratio? Because when I observed the required result, what I tried to do, I multiplied both the sides by BQ. So यहाँ BQ से multiply करेंगे तो you will get BQ upon AP. Here also you will get BQ upon CR. BQ upon BQ will be equal to 1. Okay. So I wanted to get BQ upon AP, which I have calculated here. BQ upon CR, which I have calculated here. Okay, and now I am adding them. So after adding the two ratios, because I have added the left hand sides, I have to add the right hand sides also. What I observe, I can take BQ common, which I did. Here the denominators are same, AC, so numerators will be added. So QC plus AQ, let us observe. QC plus AQ will give you AC, and therefore in the numerator, in the next step I have written AC by giving the reason A dash Q dash C. AC upon AC will be equal to 1, and now this BQ which I have taken common will be shifted in the denominator of 1, and that is what I have done in the next step. That gives you the required result. Now logically, if you want to decide the line of action, then sometimes, not sometimes, many times you have to rearrange the required result. So what I did, I have multiplied both sides by BQ and found out BQ upon AP. BQ upon AP. As soon as I see BQ upon AP, immediately I get the hint that I have to use the similarity of the triangles to get this ratio. Similarly, if I multiply second term by BQ, I'll get BQ upon CR. BQ upon CR. That means I have to prove the other pair similar. And I did that, added, and I got the result. So again, a good example we have solved. Thank you, children.